Welcome back. We are continuing to work our way through the various action condition types. In this tutorial, we look at the use of feedbacks as conditions, specifically focusing on the value 8-bit feedback. The value 8-bit is a rarely used option within iTrain. So, if you are keen to get trains running, this tutorial can be skipped. There are more important things for you to learn. However, if you are curious to know more about the value 8-bit and decide for yourself if it has anything to offer for your layout, then continue watching. Okay, so in the last few tutorials, we have already created examples where we have used occupancy feedbacks in an action condition. But as you know, there are also all of these other types of feedbacks that we could use. As far as action conditions are concerned, iTrain uses these all in the same way, as static dual mode elements that have just two states, on and off. But the value 8-bit type is different. We still treat it as a static dual mode element, but instead of having just two states, it can generate up to 256 states, having values from 0 to 255. Its purpose is to allow us to use other types of sensors or devices that are capable of feeding different information into iTrain instead of just simply detecting the presence of a train or not. That information from the sensor does not need to be train related, and the sensors do not need to be located in the track. For example, it could be a temperature sensor, or a light sensitive sensor, or a position sensor, or even the output of an analog to digital converter, if you know what one of those things are. It could be any sensor or device capable of generating up to 8-bit numbers. The term 8-bit number refers to something called a binary number. Binary is the number system used within a computer. A binary number consists of only ones and zeros. The decimal number 255, if written in binary, is 8 ones, which is 8 bits of data. Hence its name, value 8-bit, because it is a value using 8 bits of data. These standard feedbacks here also use binary numbers, but only require 1 bit of data to represent its two states, 0 for off and 1 for on. When we use a standard feedback in a condition, here's a very simple condition with just one feedback. If we use a standard feedback here, we are just presented with two states that we can choose to test for, on and off. But if we change this to a value 8-bit type of sensor, we are presented with a different window. Here we have the choice of 4 so-called Boolean operators, which work in conjunction with this value to set the condition. This value can be anything from 0 to 255, and it refers to the value sensed by the sensor and which is displayed on the value 8-bit element. So, for example, using the equal state, if the value shown on the sensor equals the value defined here, then the condition is met. With the greater state, the condition is met if the value displayed here is greater than the value displayed here. Using less, the condition will be met when the value here displayed in the element is less than the value displayed here. And with the not state, the condition is met if the value here does not match the value displayed here. And we can have combinations of these grouped together under and or operators. For example, with this condition, the condition will be met if the displayed value here is within a range of values defined by these two conditions. The condition is met if the value is greater than 4 and less than 11. Therefore, displayed values here of between 5 and 10 will meet the condition. So it would appear that the value 8-bit is a useful and powerful feature to use. But in reality, currently it is rarely used within iTrain for the following reason. Firstly, to be able to use a physical sensor or device on your layout that is able to generate the 8-bit value, it requires the use of a specific accessory decoder, the so-called OC32. Currently, that is the only hardware that is supported by iTrain for use with the value 8-bit. The reasons for that are historical. Other hardware could also be supported, but so far the demand is not there to justify modifying the iTrain software. Now, because the OC32 hardware is needed, that means you also need to have the OC32 defined as one of your interface allocations. To do that, you'd need to type new, give it a name, say OC32, and then select the OC32 from the drop-down menu and press apply. It then appears as one of your allocations of interfaces. Now, that is not a problem if you have the iTrain professional license, which allows you to have an unlimited number of interfaces. But all the other licenses have restrictions on the number of interfaces you can use. With the Plus license, you have 4 interface allocations. With the Standard license, you have 2 interfaces. And with the Lite license, you only have an allocation of 1 interface. So the second obstacle to using the value 8-bit is that it will use up one of your precious interface allocations. I don't have an OC32, so I will remove it from my list. The third obstacle is the lack of applications used within model railways that require a sensor or device that is capable of generating 8 bits of data. There currently doesn't appear to be a need. But that situation is likely to change in the future as new sensor technologies emerge. So it is reassuring that iTrain is future-proofed to some extent by already having the infrastructure in place to support up to 8-bit data streams. Okay, so let's say you do have the hardware to be able to use the value 8-bit. The setup would look something like this. This shows a typical setup for a standard feedback sensor, for example, an occupancy feedback. The sensor is located on the track and generates an off or on state depending on whether a train is present in a block or not. That information is then sent on to a feedback module such as the DigiGuise DR4088 shown here. It then sends the information into our command station, maybe the Roco Z21, and then on into iTrain. If we are using that information in a condition, that condition is set up in the Conditions tab within the Action Editor. And for all normal feedbacks, we just have the option of choosing the on or off state. If we have the hardware to support the value 8-bit, the setup would look like this. Here is the sensor or device that generates the 8-bit value, and remember, this does not need to be a feedback sensor located on the track. It could be an external device. But whatever it is, currently that information must be fed into the OC32 accessory decoder. and from there directly into iTrain. Hence the need for having the OC32 allocated as another one of our iTrain interfaces. And this time, if we're using the information as a condition, we're presented with a different window where we have access to the 4 Boolean operators. Now note that for any feedback type, the flow of information is always in this direction into iTrain. The value originates at the sensor or device and is then transferred into iTrain. I make that point because in the next tutorial we will look at another device that uses 8-bit values, but where the flow of information is in the other direction. The aspect, and that is something that we commonly use within iTrain and in train automation, and we don't necessarily need to use an OC32 accessory decoder to use it. Okay, so that's the physical setup that you need to support a device or sensor that generates 8-bit values. And I have described 3 possible obstacles that might prevent you using that feature. However, if we just want to gain access to these 4 Boolean operators and use them in a condition, there is a way that the value 8-bit can be used without the need for any of this hardware and without using up one of your precious interface allocations. And that is by using the value 8-bit as a virtual device, a device that exists in software only. To do so, just create a value 8-bit anywhere on the switchboard. So we'll place it here. We'll place a feedback sensor at that location. Double click on it, give it a name, let's say virtual feedback 2, and here we select the type called the value 8-bit. We can set the interface to anything we like. You see, I don't have an option for choosing the OC32 because I don't own one, and there's no need to give it address because it's a virtual device. So that is all we need. Click OK, apply and save, and OK to exit, and now we have our value 8-bit element on the switchboard. Because there is no physical sensor on our layout to convey the values to this display here, we have to manually change the value. Left clicking on it increases the value sequentially. Holding the Control or Command key and clicking decreases the value sequentially. If the value displayed here is greater than 0, shift clicking resets it to 0. And if the value is displaying 0, shift clicking on it sets it to its maximum value of 255. I'll reset it to 0. Here is a similar action to the one I showed you earlier, which looks for a range of values. This time the condition is met when the value displayed here is between 4 and 7. And when the condition is met, the sound file will be played. So the action is running. Nothing happens as I increase the value until we reach the value
Welcome to iTrain
of 4. And then
Welcome to iTrain.
the action is played.
Welcome to iTrain.
Each time we go through the steps
Welcome to iTrain.
until we get to the value 8, and then the action is no longer triggered. Now, I don't have the imagination to think of useful applications for this, but it demonstrates that the value 8-bit can be used as a virtual device. And just because I don't have the imagination to think of an application does not mean that you can't do so. So if you have the time and the inclination, have a play to see what you can come up with. I would be very interested to hear if you find anything useful or are already using the value 8-bit with real hardware or as a virtual device. Let me know either by making a comment below in the video, or better still by making a post on the iTrain forum, and there we will be able to search for the information in the future. Okay, that's it for this tutorial. In the next tutorial we look at the other device that also uses 8-bit values, but instead of transmitting 8-bit values, it can only receive 8-bit values. But it is a device that does have uses within iTrain and within action conditions, and that is the aspect display. Hope to see you then. Thanks for watching.